Hi, Dr. C here. Kinematic quiz. A ball problem. A ball is dropped from a height of 100 meters on Earth. Ignore air resistance. What is the acceleration in meters per second squared? What is the speed when it hits the ground? And how long does it take to hit the ground? Let's get going with that. Clearly, the acceleration for A, it's a constant acceleration. It's the acceleration of gravity on Earth. So the acceleration is equal to the value of g, which is equal to 9.8 meters per second squared. And that's equal to, just for FYI, 32 feet per second squared. That's what we use when we calculate these problems. You don't have to go out to too much precision. So part B, what is the speed when it hits the ground? What do we know? Well, we know we're falling from a height of 100 meters. Let's make the origin of X 0 at 100 meters at the top of the building. At that point, we know T naught is 0. We know the initial velocity V naught is also 0. But when it hits the ground, which is 100 meters, let's call that X. X is 100 meters. When it hits the ground, its time that it hits is TBD. And its final velocity, V, is also to be determined. So what do we do here? Well, we have one formula that we know V final squared is equal to V naught squared plus 2AX. The acceleration G is down. It's in the positive plus X direction. So we know initially that V naught is 0. So we can solve this equation for V. V is equal to the square root of 2AX. That's equal to the square root of 2 times 9.8 meters per second squared times X, which is 100 meters. Doing the math on your calculator, this becomes root 1.96 times 10 to the 3 meters squared per second squared. Check the units. And the square root gives us 44.27 meters per second. So that's the answer for part B. Part C. How long does it take to hit the ground? There's two ways to do it. First way, just use the fact that it's constant acceleration. We know that under a constant acceleration, that the velocity is equal to the acceleration times the time. We want the time, so T is equal to the final velocity, V divided by A. This is equal to 44.27 meters per second divided by 9.8 meters per second squared. Doing the math, this becomes 4.5 seconds. So that's the time using constant acceleration, method 1. Let's use another method, method 2. We're going to use the average acceleration relation, that V average is equal to delta X divided by delta T, which is equal to X final minus X initial divided by T final minus T initial. These are 0. Therefore, the time is equal to x divided by V average. But what's V average? Well, you have to compute this, but we also know, and I'll derive for you another time, that V average is equal to V naught plus the final velocity divided by 2. It's the arithmetic mean. V naught is 0, so it becomes half of the velocity. This is equal to 44.27 meters per second divided by 2, which is equal to 22.14 meters per second. So V average is that. So let's use that. Let's put that in there. So T is equal to 100 meters, the distance that it falls, divided by 22.14 meters per second. And that's equal to 4.5 seconds. So you get the same answer as up above, just a different way. Went off the camera on that. There you go.